Okay, the last procedure is to connect the battery to our parallel connection of capacitors and measure the voltages across each once again. So it doesn't really matter which one you want to connect, the first one, the second, or the third, because this plus being connected to that plus will pretty much power up all the pluses over here. And this negative terminal of power supply connected to this negative terminal will power up the negative terminals all across the connection. So this is your parallel connection. We have to switch to volts. Press the range button a couple times. And what do we know about the parallel connection? We know that the voltage across each of the capacitor must be the same. And it's the battery that powers up them all at the same time with the same voltage. So we expect 6 volts everywhere. So the first measurement, capacitor number 1, do you see the 6 volts? 5.98 right there. How about the second one? I think it's got to be 6 volts again. Boom, right there, 5.97. And how about the third one? You guessed it right, it is 6 volts again. Right there. This is what's so special about the connection in parallel. Voltage across each single capacitor must be the same, and the battery gives us 6 volts, 5.98. So 5.98 across all the capacitors, 598, 598, 598. This is the final take on the data. Now your job is to figure out the charge, answer some questions, compare the predictions with the experiment, write down the conclusion, and this concludes the capacitors lab.